Hey folks, in this video, I'm going to be going over practice set number 1 for the matching question. This time we have an example from Cambridge IELTS book number 9, test number 2, and this is reading passage number 2. So this article is going to be about Venus in transit, so always good to read that title to get a quick overview of what the article is going to be about. Now let's go down to our questions here, and the first thing that we do when we start answering the questions is we have to first mark the keywords. So right here, which keywords do you think I should mark? The keywords in the question or the keywords in the answer choices? Which keywords do you think are going to be easier to locate? If you guessed the keywords from the answer choices, then you are correct. The reason is that these keywords are proper nouns, so it's going to be very easy to find them. So we're going to be looking for all of these names: Edmund Halley, Johannes Kepler, Guillaume Le Gentil, I think that's how it's pronounced, and then I think it's Johann Franz Encke, I'm not sure, but those are the names that we are going to be looking for in the reading passage. So have these names in the back of your mind, and once you know what you're going to be looking for, then let's come back up to our reading passage and let's start scanning for these names. So here we go. Okay, I see a name here, Professor Simon Newcomb, but we did not have this name in the answer choice, so that is not going to be the correct answer for anything. Here I see Edmund Halley. Okay, so there's something about Halley right there. I'm gonna scan to see if this name appears again. I do see it appearing here. And then a little bit here. Okay, so it talks about Halley in a bunch of different places. So the word Halley seems to be quite common. I'm seeing this name again and again. So what I'm going to do, guys, is I'm not going to start off with Edmund Halley because it seems to me that this is going to be a little bit harder to find since the name appears several times. So what I'm going to do is I'm just going to move on to the other names. So I'm going to start looking for the other names, and I'm going to start off by looking for more information on the keywords that only appear once or maybe twice, not too many times, not like the word Halley. So we're still scanning, and here I see the other name, Guillaume Le Gentil. And then here it appears again. Let's see what else. Okay, nothing here. Here I see the other name, Johann Franz Encke. And there was one more name I was looking for. Have I found all of them? Johannes Franz Encke, Le Gentil, Halley. And there was one more, Johannes Kepler, right? We are also still looking for Johannes Kepler. I haven't found that yet. I must have missed it. Okay, here we go. Johannes Kepler. So that's the other name. So what I notice here about these answer choices is that the name Halley appears a few times in the reading passage. The name Johannes Kepler appears only once. Le Gentil appears pretty much only once. I think that is divided up into two separate sentences here, Le Gentil, and then here again in the next sentence. And then finally, Johann Franz Encke only appears once down here. So it's going to be much easier for me to start with any of these names rather than to start with Edmund Halley. So that's what I'm going to do. I'm going to answer B, C, and D first, and then I'm going to come back to Edmund Halley. So here we go. Let's start off with Johannes Kepler. Let's see what it says. So it says Johannes Kepler in the early 17th century had shown that the distances of the planets from the Sun governed their orbital speeds, which were easily measurable. So let's come down here and let's see which question matches up with this answer choice? Which question matches with the language that we find in this sentence about Johannes Kepler? So a good way to do this would be to simply mark the keywords in the questions. Let's go ahead and do that. So number 18 talks about calculating the distance of the sun from the earth based on observations of Venus, and it's quite accurate with a fair degree of accuracy. Number 19 says something about understanding the distance of the sun from the earth could be worked out. Synonym for could be measured or could be calculated. Could be worked out by comparing observations of the transit. And then here, number 20 says something about realizing the time taken by a planet to go around the sun. And what does that depend on? Something to do with the distance from the sun. And then finally, 21 talks about witnessing a Venus transit, but unable to make any calculations. So these are the keywords that we're going to be looking for. I see that a lot of this has to do with calculating the distance of the sun from the earth. It mentions that here and then here and here again. So when we are looking at the area around these keywords in the reading passage, then we have to look for these keywords as well and find out which question do the keywords and the connecting words match up with. So let's come back up here where it talks about Johannes Kepler. So here it's talking about the distance of the planet from the sun. So we know that we're probably going to find our answer around here. So this right here is going to be our matching sentence. In fact, that's where we're going to find our answer. And here it says, Johannes Kepler in the early 17th century had shown that the distances of the planets from the sun governed their orbital speeds, which were easily measurable. So what do you think is going to be the correct answer, guys? It's talking about how the orbital speeds could be calculated. So here it says that he actually calculated the distance. It doesn't say in the reading passage that he actually calculated the distance. It doesn't say that. Here it says that he understood that the distance of the sun could be worked out by comparing observations of a transit. It doesn't mention anything about comparing observations of a transit. So that's not the right answer either. Number 20, it says, he realized that the time taken by a planet to go around the sun depends on its distance from the sun. So this is going to be the correct answer because it's talking about how we can calculate the orbital speed by finding out the distance from the sun. So this is synonym language. It talks about how we can calculate the time taken. That can be seen as synonym language for orbital speed because the speed can tell you how long something is going to take, how much time is it going to take. So that is the correct answer for number 20. B is the right answer here. Now let's move on to our next question. Well, we don't know which question we're going to answer next, right? So let's just move on to our next keyword. So we already used B. You can put a line across it if it helps you, just to eliminate the answer choices. It can be easier for you to look at these answer choices if you're also eliminating them at the same time as you answer them. So if it helps you, go ahead and do that. So let's move on to our next answer choice, option C, Guillaume le Gentil. So here we go. So here is our keyword. So let's start reading this sentence from over here. The person who deserves most sympathy is the French astronomer Guillaume le Gentil. He was thwarted by the fact that the British were besieging his observation site at Pondicherry in India. Okay, I'm looking specifically for something to do with distance or remember guys, I'm looking for these keywords. I'm looking for distance from the sun, something about a transit, perhaps something about Venus, calculations. These are the keywords that I am interested in. So I'm not seeing anything about that here. I do see transit right here. So perhaps we're going to find our answer there. Okay, and then it talks about making accurate observations. So I have a good feeling that we're going to find our answer somewhere around there, around this area. So here it says that fleeing on a French warship crossing the Indian Ocean, Le Gentil saw a wonderful transit, but the ship's pitching and rolling ruled out any attempt at making accurate observations. Okay, so we know that Le Gentil saw a wonderful transit, but his observations were not accurate because his ship kept rolling around and turning, probably because of the ocean waves. So, for that reason, he wasn't able to make accurate observations. So, let's see, we already answered number 20. So, here it says he witnessed a Venus transit but was unable to make any calculations. So, that is synonym language. Unable to make any calculations. That is synonym language for unable to make accurate observations. So the correct question that matches up with answer choice C is going to be number 21. Number 21 is C. Now let's knock out Johann Franz Encke, option D. Let's see which one that matches up with. That appears right here. It says, Johann Franz Encke, director of the Berlin Observatory, finally determined a value for the AU based on all these parallax measurements, blah, blah, blah. I am looking for keywords related to accuracy, measurements, something to do with perhaps distance. Okay, there's transits, that's also related, accuracy. All right, more stuff about measuring, parallax principle, measure the distance to the stars. That's quite relevant. It's talking about distance to the stars, and let's see what else. Okay, and here it says how parallax shift lets astronomers calculate the distance. How parallax shift lets astronomers calculate the distance. So I remember that here it mentions calculating the distance of the sun from the earth. So let's go ahead and read this sentence. It says, knowing the width of Earth's orbit, the parallax shifts. Knowing the width of Earth's orbit, the parallax shift lets astronomers calculate the distance. So the parallax shift lets astronomers calculate the distance. So here it says, calculate the distance of the sun from the earth based on observations of Venus with a fair degree of accuracy. I want to make sure that the word Venus appears here. Alright, so it doesn't mention the word Venus here, but it's talking about transits, and I know that when they say transit, they're talking about Venus transits. So the word Venus appears in the previous paragraph, and they're still continuing that discussion about Venus and the transits of Venus. So I know that this is talking about the same thing. So the correct answer for 18 is going to be D. Johann Franz Encke, he was the one who calculated the distance of the sun from the earth. Great. Now let's knock out our final question, number 19. The answer is probably going to be A, Edmund Halley, but let's go ahead and make sure anyways. Let's make sure that that is in fact the correct answer. So here it says Edmund Halley. This is where it first appears in the reading passage. So let's read this sentence. And you can put it all down to the extraordinary polymath Edmund Halley. In November 1677, Halley observed a transit of the innermost planet Mercury from the desolate island of St. Helena. He realized that from different latitudes, the passage of the planet across the sun's disk would appear to differ. Okay. And check this out. Down here is talking about how we can calculate the parallax angle, and it's talking about talking more about calculation and calculating the distance of the Earth from the stars. So our answer is probably going to be around here where it mentions the distance of the Earth from the Sun. So here it says, let's read this sentence. It says, calculating this angle would allow astronomers to measure what was then the ultimate goal. It would allow astronomers to measure the distance of the Earth from the Sun. So here number 19 says, he understood that the distance of the Sun from the Earth could be worked out or calculated, that is synonym language, could be calculated by comparing observations of a transit. Okay? Comparing observations of a transit. So here we are talking about calculating the parallax angle. And when it says parallax angle, we are talking about the parallax angle of the transit. Okay? It mentions that over here. It's talking about measuring the transit. So by timing the transit from different angles, we could calculate the parallax angle. And this could help us to determine the distance of the Earth from the Sun. So that is in fact the correct answer. The answer to number 19 is A, Edmund Halley. Awesome. So we are now done with this question set. In the next video, I'm going to be taking you through practice set number 2.